All right, we're going to calculate the gear ratio of this little car. So you can see right here, I've got a small gear attached to the motor, or the shaft of the motor, which I'll take out in a second. And if we follow the rubber band, flip the car over, we can see that there's a larger gear connected to the front axle of the car. So we're going to calculate what's called the gear ratio of this car. So let's go ahead and take off the rubber band and take off this gear, which will expose the motor shaft. There you go. So this little stick coming out of the motor is called the shaft, the motor shaft, and this is the spur gear. It's actually not a gear, it's actually a pulley wheel, but it's similar to a gear. And then we'll go ahead and go to the bottom. Whoa! And we'll disassemble the car. And we have our gear connected to the front axle. So now what I'm going to do, I'm going to measure these two parts. So to calculate the gear ratio, right? The gear ratio is simply the diameter of the out gear divided by the diameter of the in gear. Okay? Now the out gear is the one connected to axle, right? Connected to the axle. And the in gear, it was the one that's connected to the motor. Okay? And then you just make a ratio of 1 over the other, and you can express it as a fraction, you can reduce it as a simple number if you divide the two numbers. So let's go ahead and figure out what those are using a dial caliper. All right, so this right here is a dial caliper. So this is 0, and as you can see, if you follow the green numbers, right now, I'm going to zoom in a little bit so you can see it better. I'm at about 0.07, 0.10, 0.15, if I can get it right there, 0.20, 0.30, 0.50, that's half an inch. And then if you go all the way around back to the 0, you notice down here it says 1. That would be 1 inch. So the distance between these two teeth on the caliper will be 1 inch. All right. So this would be more than an inch, 1.10, 1.20, etc., etc. So let's go ahead and grab the larger gear. And I actually want the diameter not of the entire wheel, but where the rubber band will go around. So I'm going to clamp down on the wheel, like so. I'm going to try and turn the camera to capture that. Okay, so I'm measuring the inner diameter of the outer portion of the wheel. All right, it's more than 1 inch. So it's right on, looks like I'm going to hold this in the middle, zoom in. It looks like it's really close to the line, so 1.40 inches. Now technically with the dial caliper you can estimate, if you're saying it's right on the line, you can add an extra 0, so that'd be 1.400. If you're saying it's just before 1.40, right, just before the line, then you would say 1.39, and then you're allowed to estimate 1 extra digit. We'll just say 1.40 for the sake of this video, 1.40. All right, so that would be my D outer, 1.40 inches. Okay, and now we've got to get the inner diameter. So we're going to clamp down inside of here. That's much less than 1 inch. We'll zoom in. And that's, see this one, it It's not quite on 0.21 or 0.22. It's kind of in between. So it's definitely greater than 0.21, but definitely less than 0.22. So we're allowed to estimate. So you could say 0.21, and then you can add one extra digit. So I'm thinking it's right in between 0.21 and 0.22. So I'll say 0.21, and then I'm allowed to estimate one extra digit. I thought it was halfway to 0.22, so I'm going to make that a 5. Now, just for the sake of consistency, the 1.40 I thought was right on the line, so that extra digit that I'm going to estimate is actually a 0. So I get 1.400, which is 1 in 400 thousandths, over 0 in 215 thousandths. Now, if you go ahead and divide those numbers, right, if you're trying to express this as a number over 1, right, you could divide these two numbers. So let's go ahead and do that right now. It's about, looks like it's going to be about 7. And I got 6.511. We'll just round it to 6.5. So our gear ratio is about 6.5 to 1. And you could express that, using a semicolon. There you go. Either of these are ways to express a ratio. All that means is that the diameter of that outer wheel is about 6.5 times as big as the diameter of the inner wheel. Okay? And what that does is that means this is going to spin around 6.5 times in order for this big wheel to spin around once. So the little one's going to be spinning fast, the big one's going to be spinning slow. And that big one is connected to our front axle, so we're not going to get an increase in speed, we are going to get an increase in torque, which is a turning force that allows the wheel to, have more power if it needs it. For example, when you're trying to move heavy weight or maybe climb a steep hill.